Hi, have you been trying to learn agentic development? And are you trying to understand what is a skill, what is an agent, what is a sub-agent, what is a tool, what is a hook, what is a plugin? Are you trying to develop a mental model and try to make a sense of what goes where when you are trying to create a AI setup for your repository? And you still keep getting confused between what to use for what purpose and what is meant for what. If this is what you are trying to make sense of, then this video is for you. At the end of this particular video, you should be able to understand what all these things mean and how to use them and what purpose do they serve. So without much further ado, let's get into it. So when you hear these jargons, don't directly get into the definition of what these things are. Instead, keep the agent, which is a decision making body, which is basically the LLM that is doing the decisions, and then try to answer the questions such as who is guiding the agent, how agent delegates to something else, what is getting exposed to the agent which are external to the agent, what a agent can call and what automatically runs without the intervention of agent, and is it possible to package all of these things together. So when you try to answer these questions in a logical way, that is when all those different words start making sense. So let's start from something very beginning, which is a user request or a user goal. This is something that you initially start your interaction with a agent. The goal is something like create a PRD or create a architecture plan or create a execution plan, or it could be as simple as write a function to add two integer numbers. That is the goal, and you give it to an agent, and based on the goal that you give, agent decides to do the next. So whatever that is taking the decision what to do next, that is a agent. But once the agent decides what to do next, it needs something to do, that is the tool. Think of tool as a callable action. When you gave it a goal to write a function to add two numbers, once it has decided what that function is going to look like, it has to create a file, it has to name that particular file with a proper extension, and it has to start editing that particular file. So to do all that, it needs tools. In this case, tools that basically help the agent to do the file editing, and that is what a tool is. It is a callable action that agent chooses to call, and tool does its work and sends back the result to the agent. So if you can think of, it could be tool call like a execution of a bash command, reading of a file, or say for example you want to access something from the GitHub issues and even do static code analysis. Think of this like function call. That is what a tool call is. These are the actions that the agent may choose to call. Now, agent cannot randomly call any tool. It has to be dependent on some kind of a logic or some kind of a process which helps it to decide to call a particular tool or do something. And that is where the skills come into picture. Think of skills as a playbook, set of rules or set of instructions that will guide the agent to do something. For example, you can have a skill called code review, and in that code review folder you will be having a file called skills.emd, and it will be having a name and description. In this case, it will be name like code review and description review the code for quality and maintainability. And then you will have instructions in that particular skills.md file. In this case, it would be something as simple as inspect the differences first, the git differences, identify the behavior change, and check the tests and the edge cases. Maybe you can add few more instructions like go through the initial instruction that was given and then compare it against the work that was done. what is the sonar cube result that you have got, check against that. So it can be as elaborate as possible depending upon how you think your code review skill should behave. And once agent needs to do code review, it will refer to this particular skill.emd file. But if you start writing one single agent as one huge file, it can become very difficult to manage because of the context window constraint. I have talked about it in another video. Please check it out. So sometimes skills are good, but then you also need to decide if some specialized processes have to be followed, then it would be better to write those things in a sub agent. So think of it like a specialist worker to which agent basically delegates its work. For example, you want to commit a file to the Git, and as a part of that, you are following a certain specific arrangement on how to do it. Then that can be done using a sub agent. You can write a specialist sub agent for that, and agent will decide that I will not do this on my own. I will delegate it to a sub agent. Sub agent might itself have skills and might itself call certain tools. But to keep it simple, you can think of it like child agent which a parent agent can delegate to. This is how it might actually look like. For example, I might have a code reviewer agent. It will have a name, it will have a description, it will have a declaration of tools that it can use. For example, it can read file, it can do grep and glob, and what kind of model the agent supposed to use. It is good idea to declare the model that you want to use with a particular agent, because the model cost has become a major bone of contention. The frontier models like GPT 5.5 or Opus 4.8, if you run everything in the highest frontier model, you are going to run out of tokens very quickly. Instead of that, if you declare what model the sub agent should use depending upon the complexity of what that agent is trying to do, then the number of tokens that you will end up burning will be significantly lesser than what if you had not done this. So it is better to write a model, and then in this case, I have just written you are a code review specialist, but you can once again write a very detailed instruction set in this particular code reviewer agent. To do this, if it wants to use a skill of code review, it can of course use it. So think of it like defining specialist worker with skills. But other than these things, other than the agents, tools, skills, and sub agents, whenever the agent is doing something, you want to track what it is doing, or you want to execute something automatically when something happens. For example, let's assume that agent tries to write to a configuration file, and that configuration file is sensitive and you don't want the AI agent to touch that particular file. Before agent tries to modify that particular file, before that tool call happens, you want to intercept that particular tool call and want to check that is it trying to edit a blacklisted set of files. If it does, then you don't want to allow it to happen. So that is where the concept of hooks come into picture. So you can write hooks for doing certain validations, logging certain things, or approve certain things, so that agent run is properly automatically managed and observed. That is where the concept of hooks come into picture. For example, before tool use, you want to basically check certain things, and you will write a pre-tool use hook which does that. Or every time call goes to agent, you want to log how many tokens have been consumed, and after that how many tokens have consumed. So you want to basically keep a track of how many tokens are getting consumed between the tool calls and between the agent calls and between the MCP calls. You don't want agent to do this. It should be automatically be intercepted by another layer and taken care of without the intervention of any of the agents or skills. That is where hooks come into picture. Think of them like a interceptor you might have written in a OKHTTP or a middleware whenever you are making a REST API call, something like that. But this is for the agentic development. And other than this, there is a concept of MCP server. What is a MCP server? It basically extends the capability of tool. Instead of writing one callable function again and again in the tool, MCP server is like a protocol which will be used to extend the capability of tool callability. For example, let's assume that you want to call GitHub related tool calls. For example, you want to get all issues from the GitHub. You want to get the GitHub actions that have run. You want to get PR details. Instead of you writing the custom functions in the tool, you want to bunch them all together like a reusable package, and you basically give it to anybody who is doing the agentic development. They can just install that particular MCP server, and if you have that particular MCP server, they can use it. So you can think of it like another port to your tool, using which the agent can interact with the external world or external systems. GitHub MCP server is one thing. You can have MCP server for MongoDB. You can have a GitHub action for the Azure DevOps. So anything that is external, if they want to expose certain functionalities from their system to the agent world, it can be done through a MCP server. MCP server basically stands for Model Context Protocol. I have another separate video on how this MCP server works and its internals. It basically nothing but a bunch of tools and prompts and resources. Resources could be like URLs or a context that would be relevant to make a tool call from the agent. So that is what the MCP server is. This is how the MCP server declaration might look like. For example, this one is a file system MCP server, which is used for accessing the file system on your computer. And at the end of the day, this is what actually is there whenever you are working on a repository. In a project repo, you have agents, you have skills folder under which you declare multiple skills, and then you have agents folder where you write multiple sub agents, and then you have hooks, which are basically lifecycle checks and interceptors. And then if at all you need any MCP server, then those will have to be declared in the mcp.json file. And pretty much all agentic platforms, be it GitHub Copilot, Claude, or OpenAI's Codex, they pretty much use the same concept. Maybe they will place these things here and there, but the concept is pretty much same. This is how it might actually look like. They are almost one and the same, just that file format, naming convention might be changing here and there. When you are trying to choose any particular framework, don't think that if you learn Cloud, you will be stuck with Cloud only. You can switch to Codex or you can switch to Copilot, provided you understand these underlying fundamental core concepts. And it is possible to create a repository with AI setup that can work seamlessly across different frameworks in the same repository. I will show you a sample repository where I have set up this so that you can actually get an idea how a real world setup looks like. This is one of my personal repository that I am working on. Don't worry too much about what the project is. Just concentrate on how I have arranged these things. So this is a GitHub, and here I have Copilot instructions. And if you can see here, I have declared the custom agents and custom skills. What is the agent, what it does, the purpose, and what tools it uses. So let me show you in the preview. So I have agent, purpose, and what tools it uses, and then custom skills. What are the skill and when does it get triggered? For example, I have a skill called author implementation plan. It gets triggered whenever I am turning a PRD into a detailed implementation plan. And then I have something called as add LLM task. This is a LangChain project. That is why I have this skill. And then adding a new LLM powered generation step. That is what skill is. And if you see here, I have also given where they are. For example, if you go to the agents subfolder, I have all these agents declared here under this. For example, creator ops architect agent. If I just preview this, it basically says what this agent does, what is the name of the agent, what tools it uses, and what other sub-agents it uses, and constraints, what are the required references, how it should work, and everything. Each agent has something similar. And then if you go to skills folder, I have these multiple skills. For example, execute implementation plan task. So if I just preview this has a skill on how to implement a planned task. So once I create a task, how it should be implemented, what branches should be created, where it should be committed, where it should be pushed, or should the PR be created, what is the convention to create the PR, should I write the test cases, what is the minimum threshold, all those things. So this is how it would actually look like. Now, once you have created these things, you might start seeing a very good results. You will get consistent review outputs. You always have a safer command set with the hooks. You will be able to manage better context in your project, and you basically have a reusable workflow. So this is no more a local tweak. Let's assume that you have set it up in your local repository and you are working in a team. It would be good to not keep it with just yourself. So if there are around 3 or 4 different people in your team, you can't tell them use this skill file or use this agent file or use this hook. So if you start doing that, then more often than not, they might actually go wrong. There will be some kind of a drift, some files will be missed, proper versioned skills and agents might not be used, and it is very difficult to even update. That is one of the major problem if you try to manually distribute your things. So that is where the plugin concept comes into picture. So once you have this gold standard of skills, agents, sub-agents, tools, MCP server, and hooks, you want to create a plugin package. What is a plugin package? Think of it like a NPM package. Just like in NPM, you distribute a SDK or a workable code. In the plugin package, you basically distribute all these skills, agents, hooks, MCP config, and assets that you have created. So this is like a NPM package of AI configuration that can be distributed across the teams. So just like you have a NPM registry, and from the NPM registry, you can download a NPM package. Plugin in AI sense is a distributable package of skills, agents, hooks, MCP configs, and assets. Once you create this, you can install it like a reusable setup across the team. So you can create this package and tell all your team members that I have created this plugin, and they can install it and start using it in their repository from day one. They don't have to worry about what skills have to be created, what tools have to be added. It's all there. So you will have Codex plugin, Cloud plugin. Both of these frameworks have their own mechanism of creating plugins. Slight difference will be there here and there, but the concept pretty much remains the same. So this is what a plugin is. One of the common mistake people do is they confuse tool, skill, and plugin. They are not one and the same. Tool is a callable action. It basically does a work when called. Skill is like a reusable playbook. It basically guides how agent approach a task, and plugin is a installable package of AI setup. It distributes the assembled AI setup for everybody like a reusable NPM package. So it's action, guidance, and distribution. Going forward, whenever you are wondering whether something should be an agent or something should be a skill or something should be a MCP server, try to answer these questions. If it is something that has to do the decision making, it should be an agent. If it is something that should be callable by the agent, it is a tool. If it is something that should be used by the agent to control its behavior, then it should be a skill. And if it is a specialized work which the parent agent can delegate it to a sub-agent, then it is a sub-agent. Something that needs to run automatically without the intervention of agent, it has to be a hook. And if there is an external world which needs to be exposed to the agent, probably it is a MCP server. And plugin is combination of all these things that is easily distributable to the any developer. So that's it in this particular video. Hopefully now you have a better understanding of what all these things are. If you do have any questions, please put them in the comment section below. I will try to answer them. Thanks for your time. That brings us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.